All right, so when you guys do inverses in math, I don't always use the word inverse, but when we do inverses in math, like if I needed to get rid of that +4, maybe it's something like this. Instead of adding 4, what would be the inverse of addition? We would subtract 4, right? And that's how we're able to isolate a variable by using an inverse operation, and we can do it for both sides because it's an equation. What would be the inverse operation of multiplication? Excellent. What would be the inverse operation of squared? What would be the inverse operation of a cube root? Cubing. Good, good. What would be an inverse operation of an exponent that had a variable? Oh my gosh, that is a world record. Say it again. Logarithm. Good job, good job. We're not going to do logarithms today, but that is what is the inverse of a base of 3 to the x. You would do log base of 3. That would be its inverse. Excuse me. What we're going to do is just talk about inverses and their graphs and their ordered pairs and how we find them. So super, super easy. X plus 4, x minus 4. These are inverses. This one you add 4, this one you subtract 4. Okay? Let's quickly just graph the graphs x plus 4 and x minus 4. How would I graph x plus 4 or x minus 4? They're what kind of? They're linear. How would I graph those? How do we graph one? Oh no. How do we graph line? You use the slope from where? From the y-intercept. So we begin at the y-intercept, we start at 0, 4, then we use our slope, rise over 1, excellent. Okay, I'm going to do that real fast because we've already taken a quiz on that. It's Algebra 1 content. Same thing with x minus 4, we would begin at 0, negative 4, use our slope. If we look at a table of values, okay, if I look at a table of values, those are the ordered pairs. I'll just make them bigger on this graph. Maybe two piece in there. What I want you to notice, and what's really cool graphically about inverse functions or inverse equations, is that they always reflect in the y equals x line. I'm going to write that down. They reflect in the y equals x line. Inverses always share them. So if I made y equals x, that dashed line in the middle, if I made that a mirror, these would totally flip over each other and be reflections of each other. And because of that, you know, I can put any table of values I want for the purple one. Bless you. But this, for real, is some of the ordered pairs on the on the purple equation. They're the ones that I made darker, kind of darker. They're the ones that reflect right there over the y equals x line, these right here. And what can you tell me about the blue ordered pairs compared to the purple ordered pairs in the table? Opposite, they kind of, opposite means something else in math, but they just like switch their spots. The x became the y and the y became the x. And that's something else about inverses that are really important and always true, is that if we have a table of values, the inverse values are just take the x and y and switch them. So there's two things about inverses that are always true, and we'll talk about the equation in just one moment. One other thing in this paragraph at the top is when we write the inverse, so if the original equation f of x, if it's in function notation, if the inverse is also a function, we would either write g of x, or you could write f to the negative 1 of x. Either of these is acceptable for writing the inverse of the function. Either give it a different name, or show that it's the inverse by putting that negative 1. Both of those are acceptable, okay? I don't care which one we use. Can I move on? So the next stuff you don't have to write anything for, but it's just talking about how we could tell that these equations are inverses. So here's two equations that are inverses of each other. And if I were asking you what is being done to the x in this equation, you would say, first, you multiply by 2, then add 3. So if I gave you an x value like 1, you would first 2 times 1, then add 3, right? First multiply by 2, then add 3. This is its inverse. What would I do to the x value here? I would first subtract 3, then divide by 2. Do you see how these operations are opposite and in the other order? That's what makes them inverses. They're undoing each other. They're going in opposite order and they're the opposite operation. So this is one way you can find the inverse. However, this is not my preferred method, but it might be your preferred method. You just think about what is being done to the x, and you like rewrite it in the opposite order, in the opposite operation. And here's what I just talked about with the first equation. Here's the table for those two equations, and you can see that the x's and y's are all switched. You can see with the slope of 2 and the slope of 1/2, they reflect over in the y equals x line. That's all just visual, just showing you the same stuff we just talked about. So now let's do it for you. You're going to do this for your assignment. Find the inverse of x equals 3x minus 1, and then we're going to graph the function and get marks. I talk a lot without taking a breath, please. First, let's just sketch the y equals x line. Because when we're done, we want to make sure that our two graphs do actually reflect in the y equals x line. So in your assignment, it's going to say, first, it's going to tell you to do that. Let's go ahead and do that. Oops. So the y equals x line, sorry, I didn't really say much about it, but y equals x line is when all the ordered pairs have the same y and x. 1, 1, 2, 2, 3, 3, 4, 4, 2, 0. Next, what we're going to do is let's just graph the function itself. F of x equals 3x minus 1. Or you can think of that as being y equals 3x minus 1. So we'll begin at 0, negative 1. Use our slope of 3. Go ahead and graph that. remember, I'm going pretty fast because I want to make sure all the notes get done. If I go too fast for you, you can always get on Canvas and see what you missed or ask me a question or tell me to slow down. So we're sketching y equals x. We're going to graph the original. Now I'm going to graph its inverse. Nope, I'm going to find its inverse. Then I'm going to graph it. You can find it by just thinking like, oh, 3 times x, take away 1, it's got to be the opposite operation in the opposite order. You could write the equation that way. Or we can solve it algebraically. I'm going to show you how to solve it algebraically. You can do the thinking part if you want to do it that way, but I'm going to do it algebraically. If we solve this algebraically, to find the inverse, one major step. I'm about to do it. I'm giving you lots of warnings so you don't miss it. It's really important to find the inverse algebraically. You ready for this? You ready? You ready? I'm going to switch the x and the y in the equation. So here's the equation. I changed f of x into y because I was graphing it. I'm going to switch the x and the y. Here I go. X equals 3y minus 1. That's the inverse. I did it. Hey. We're not into it as I am. Okay. That's the inverse. Not too bad, huh? However, if I'm going to graph that, I probably don't want it in x equals notation. I probably want to change it to be y equals mx plus b, correct? Okay, so let's go ahead and take it further. And we will be doing this. I'm just joking around. Like, this for real is the inverse, but we will be solving it for y after you do this. So I'm going to add 1. And then how do I get rid of 3? What's the opposite operation? So I can divide by 3. I can divide by 3. Or, instead of dividing by a number, you could also multiply by its reciprocal. So we could instead multiply by 1/3. Either is fine. Either of these is fine. It's just, which one are you going to use to graph? Are you going to use like x plus 1 divided by 3 to graph, or would you use 1/3 x plus 1/3 to graph? You'd probably use the bottom one, right? But I don't know. I'm not a big fraction person. So there's other ways to graph it. You could find the x-intercept. There's other ways to graph it. But when I'm done, what do I know about the inverse and the original function on the graph? Katie? The x and y just switch. So guess what? That's all I'm going to do. I'm not going to graph this line. You can and just make sure they're right. But I'm just going to like pick some ordered pairs. Here's what is this ordered pair? 1, 2. And I'm going to graph 2, 1. This ordered pair here is 2, 5. So I will graph 5, 2. I know the slope has got to be 1/3 from my equation, or even just finding the slope right there is 1/3, so I can use that slope to find more points. So we've gone over different ways of graphing lines. You can use whatever method you want, but since it is an inverse, you can also switch to x and y ordered pairs to graph it. I'm just sorry. Don't make me think. One more thing. We have to check to see if the inverse is a function. And remember, to tell if it's a function, it has to pass the vertical line test. So is my inverse, so it's a terrible vertical line. Try that again. Better. Is my inverse, the purple line, is that a function? Does it pass that vertical line test? So since it was given in function notation, I'm going to write the inverse in function notation as well. So you can either, you can either use g of x, or you can use f to the negative 1 of x. Either of those is fine. 1/3 x plus 1/3. Or you can write the or you can write this one this way. Either. They all mean the same thing. If it was not a function, you would just write y equals. You wouldn't write f of x or g of x. Okay. Question? Good one? So then when we have non-linear functions, here's two examples. We've got a parabola, we've got a quadratic in blue, and then when we do the inverse of that, we reflect it in the y equals x line. You can see that it's now a parabola facing to the side. How would I graph that on the graphing calculator? Do you know? Let's talk about it. So f of x equals x squared is the original function. They tell us that the inverse is x equal y squared. But I've already told you we're going to solve that for y. Okay? So we're not going to leave an inverse like that after we switch the x and the y. This was, this is the same thing as y equals x squared, right? So they switched the x and the y to get the inverse. But we're not going to leave it like that. We're going to solve it for y. How do I solve this equation for y? Think? Square root of what? Both sides, yes, yes. Okay, so by square root of both sides, I'm going to get, I'm going to get y, no, this is good. Y equals square root of x. Y equals square root of x is something that we've been studying and is on your quiz tomorrow. What does a square root of x graph look like? Is that this? Half of it is, yeah, like the top half. This is square root of x. How do I make it do this? There's something when we solve the equation that we forgot about, or it was not driven into our memory last year. Who had me? Yeah, who said that? You, yeah. Remember, plus or minus, if you square root, you got to put a plus minus in there too, because you don't know what x was originally. It could have been a positive or negative, and then when you square, I'm sorry, it's actually y. You don't know what y was, but when you square it, it becomes positive. So you don't know what it originally was. So yeah, we put a plus or a minus in there when you square root. So now, this is going to give us both the positive and the negative part of that square root function. How can I remember that the positive is this part and the negative is this part? No idea? Brandon, can you explain to anybody else who's like, I have no idea. How can I remember the positive is this part and the negative is that part? Yeah? Okay. Good. So sometimes logic is helpful. So anyway, is this y equals plus or minus square root of x, is that a function? Tristan? Why?
Because you can get two answers on a vertical line test.
Mm-hmm. So it's not a function. So would I write this as g of x equals? I would not. How would I write it? Just like this. Okay. The only difference is you're just not going to write it in function notation if it's not a function. Okay? Cube and cube root, those are both functions. And in fact, all odds are going to be functions and all evens, when you flip them, are not going to be functions anymore. Unless we have something like that. So we did piecewise functions to work into this part. Does that look like when we were doing piecewise? Remember we had some pieces at the end that said x is greater than or equal to -4. Brenda, can you explain to me what this tells me to do when I graph it? What variable am I restricting? I'm restricting the x, so that goes up, down, left, right. Where's that x? Left, right. So which direction am I allowed to graph the x's? To the left or right? So the right of what x value? Perfect. So this is when we're doing those piecewise functions. I'm only allowed to graph the original function to the left or to the right of -4. Okay. So let's sketch y equals x line, and let's sketch the original function. And you guys have a quiz tomorrow on transformations. Thank you. So I'm going to graph this using transformations. You know, some good practice for that quiz tomorrow. So I'm going to graph y equals x plus 4 squared. That plus 4, well, first of all, what kind of parent function is it? Parabola? Quadratic? Is there a stretch or a shrink or reflection? No, it's just what? Left 4. So we're going to take that exact same shape, go to the left 4. If you need to make a table of values, go ahead, but for time-wise, I'm just going to graph that answer. So we would end up here, and it would mirror, except there's a restriction on my domain that says only graph x's that are greater than or equal to -4. So I'm not graphing anything on the other side of that parabola. We just did that with piecewise function. Now I have to find the equation of this, and I have to graph the inverse. Can I graph the inverse without even finding the equation? Yes. Can. How? Just switch your x and y values. So if this one's -4, 0, we've got -3, 1. This one, -2, 4. 1, 9. I'm just going to switch x and y. So what happened there? Right. But, so it's only part of the parabola in blue, only part of the parabola, so that means only part of the square root is going to be graphed. So now I'm going to find it algebraically, so we're going to do the inverse, algebraically, inverse, that means we're going to switch the x and y in the equation. I'm going to do it algebraically. Here we go. X equals y plus 4 quantity squared. Did it. Found the inverse. Woo. But we don't leave it like this. We're going to change it so it is in the form of y equals, and is this a function? This purple one, is that a function? Pull out a vertical line. Does it ever pass more than once on a vertical line? So is this a function? So when I'm done, I'm going to write this in function notation. It's going to be like f to the -1, or it's going to be g of x. I'm going to write in function notation. So we have to solve this. So you look at what's being done, and you undo it in the opposite order. What's the outermost thing that I need to get rid of first? So how do I cancel out squared? Square root. I heard a plus or minus in there because that's the correct rule. So now I have plus or minus square root x equals y plus 4. Then what do I do? Subtract the 4 So I'll have a plus or minus square root x, and then I'm going to have a minus 4. Now I'm going to look at my graph and say, is this true? Is my graph really the positive and the negative square root at minus 4? Are there two pieces to that graph at minus 4? Because, why? Up here, we had a restriction saying only use the x's that are greater than negative 4. So down here, I'm only using which x's? That are positive. So when I rewrite my final answer, I don't need that negative side. I just need to make sure that it's matching my answer. So I'll write either g of x, or I'll write f to the negative 1 of x equals square root positive square root of x minus 4. Question? So I feel like if you have the picture, it's going to be easier to figure out what part of the equation you're using, if there is a part. Sometimes you use the whole thing. I've already talked about the vertical line test. There is something called a horizontal line test. That would be before you flip it, before you reflect it. You could tell if it's going to have a function or not. Like if I graph a parabola for my function, if that's my f of x, when I go to flip it, is it going to pass the vertical line test? If you're not sure, you could do something called a horizontal line test. If it doesn't work horizontally, then it's not going to work vertically when we flip it. That's what that says. I think that's more to think about, so I just flip it first and then do horizontal. Also, what did I say about if it's even? It's not going to be a function when you flip it. So this one here, we're not going to go through this whole example. Let's just look at the graph or the equation. F of x equals 2x to the third plus 1. So we know what cubic looks like. Do we know what cubic looks like? Okay, and then multiply that by 2. What's going to happen? What's times by 2 do? It's on your quiz tomorrow. What's times by 2 do? Stretch what kind? Vertical stretch, right? And then what's plus 1 go? Up 1. So we're going to have it like stretched more and then up 1. Still like this. When I flip it, is it going to be a function? Yes. If you use the horizontal line test now, it works, or you can flip it. Kind of hard to flip that one, but nope, that was bad. That one didn't work. Here, that's better. You can use the vertical line test and it works. Okay. This one will actually function. Consider the function f of x equals 2 square root x minus 3. Determine whether the function, whether the inverse of f is a function. Then find the inverse. So we have to determine whether the inverse is a function, and we have to find the inverse. So what's the square root look like? If there's a 2 on the outside, just stretch it vertically, and if there's a 3 on the minus 3 on the inside, right 3. So I like something like that. Is the inverse going to be a function? Oh. Okay. Thanks. Bye. Your answers to the review will be on Canvas, they're not yet. And then this is due Friday. Oh, actually, it didn't copy the notes. All right, guys. So when I do reflect this in that y equals x line, will it still be a function? Okay, well, let's do it. Let's find the function. So if it's f of x, I'm just going to make that y equal so I can see x and y. And then I'm going to do the inverse. There's the big inverse step. Here it is. I'm going to do the inverse. What am I going to do? What am I going to do? Nick, what am I going to do? Which x and y? So I have now x equals 2 square root 1/3. All right, then we have to undo everything that's being done to the y so we can get y by itself. And divide by 2 or multiply by half, however you see it, it's fine. Nay, do you know what to do next? Square, well, both sides. Whole thing, the entire side. Square the whole side. So actually I have x squared over 4 equals y minus 3. And then I'll solve that for y. I'm going to get y equals x squared over 4 plus 3. I'm going to use my graphing calculator to make this go a little faster. In your homework, you're going to graph it as well. But for right now, we'll just look at the graph. There's my original square root. There's my inverse. What's wrong? I'm here research. You change mine? Logan, do you know?
Well, one's a parabola.
Right.
It's not complete accurate.
Oops. So what Logan is our original graph? Is it the blue or the red one? Blue one's the original one. So if I'm going to totally reflect the blue one over,
Should we say x should be greater than or equal to 0?
totally.
The problem is there's too much red one. There's too much red one. We only want this part to reflect over. And this is it's not a square, so that's why it looks a little skewed. But we don't want that part. So if I graph that entire y equals x squared over 4 plus 3, I'm getting the entire parabola. But that entire parabola is not the reflection. It's only part of it. So we're going to go ahead and add a restriction to say only, oops, to say only that part. There we go, one more try. There we go. Only that part. So I'm going to have, and is that red part a function?
Yes.
Yes, okay, so I can write it as g of x equals x squared over 4 plus 3. I'm going to add on a restriction at the end that says just use x values that are greater than or equal to 0, just to the right of 0. So I feel like the most challenging part is just if there's a restriction, figuring out that restriction. I think everything else should be pretty easy. Okay? The rest of these notes, if we have time after the quiz, we might do it, and if not, then I will expect the rest of the worksheet done. The part of the worksheet that will need to be done by Friday, as of right now, is 1 through 6. The rest of it we didn't cover. So I want to give you an opportunity to ask questions about before the quiz if you have any. Let me stop this video.